In my previous video, we discussed what a midpoint was and how to find it on the coordinate plane. Here, we're talking about a midpoint of just a regular line segment and needing to solve for the missing variable. So again, keep in mind that a midpoint cuts a line segment in half or into two smaller congruent pieces. So anytime, so it says right here, y is my midpoint. So by definition, that means xy is congruent to yz. Okay, so if the two smaller segments are congruent, therefore their measures are also equal. So to solve for A, I'm just going to write xy equals xz, okay, and then, so that means 3a is equal to a plus 14. Okay, so if the segments are congruent, therefore their expressions are also congruent. So subtract a from both sides. We get 2a equals 14. And I know it looks like a 9, not an A. Sorry about that. And then divide by 2. So A equals 7. But let's go back and reread the question. It wants the measure of xy. Okay? So 7 is what A equals. So we then have to substitute. So xy is represented by 3a. So I need to substitute a in. I need to substitute 7 in for a because that's what we solved a. That's what a equals. So our final answer and the value of xy is 21. Okay. These next two problems are exactly the same. We are told that we have the midpoint. Q is the midpoint of PR. B is the midpoint of AC. So therefore, AB is congruent to BC by definition. Anytime you see that term midpoint, we can assume that AB is equal to BC. So 5x minus 3 equals 2x plus 9. So all I did was substitute the expressions in, because if the segments are equal, so are their values. So subtract 2x so I can get, remember x is on one side, and then we have to get our constants or our numbers on the other. So subtracted 2x from both sides to get 3x minus 3 equals 9. Add 3 to both sides, so 9 plus 3 is 12. My last step is always to divide by 3. So x equals 4. Go ahead and pause the video, try example number 3. Hopefully some of you caught the fact that while for example number 2, I found the value of x, I did exactly what I told you not to do, which was stop and go back and reread the question. And the question did ask for the length of AC. So 4 is x, minus 3. Remember, in order of operations, we always multiply before we subtract. So I have 20 minus 3. So the length of AB is 17 units. For example 3, after you do your algebra, you should get x equals 4. And again, it's asking for the length of P, ooh, be careful, PR. Okay, so notice the difference. And actually, I didn't even read this correctly. I solved for AB, not AC. This is what happens when we rush. So let me go back to example number 2 here, AC. I only found, when I plugged, on example number 2, when I plugged 4 in for x, I found the length of AB. So I know that AB is 17. But if you notice, AC is the entire length of the segment. So because B was the midpoint, both segments are equal to 17. You can always confirm that by plugging x in, 4 in for x. 2 times 4 is 8, and plus 9 does equal 17. So 17 plus 17, the length of AC equals 34. And that would be my correct and final answer. Here, example 3, yep, we want like the PR. As I mentioned, when you do the algebra, you're going to get x equals 4. So if I plug 4 in for x here, and then minus 4, I'm going to get 44 minus 4. Oops, sorry, which gives me 40. So again, they're both segments are equal. So my final answer and the length of PR is 80. Okay. So that's finding the solving for using algebra to solve for the length of using algebra to solve line segments with a midpoint.